I've had the opportunity over the last year or so to meet with customers around the world, and if there's one thing I'm seeing clearly, it's that cybersecurity is no longer an issue just for the server room, it's an issue for the boardroom. Our customers know that there's just an enormous amount at stake. You can lose the value of your brand if there's a hack, an attack in your organization. You can lose your reputation. You can lose your customers. Senior executives can lose their jobs. And the very thing that makes you competitive, that differentiates you in the marketplace, your intellectual property, can be taken. One of the things I'd really point your attention to of the sort of data points on the screen right now is the first one, that the median number of days before an organization is even aware that it's been attacked is 243. 8 months going by before an organization knows it's been compromised. The Cybercrime Center is based at our headquarters in Redmond. It's where I work with the Digital Crimes Unit. We're a team of about 100 people, and we're focused on creating a safer digital world so that everybody can use the internet safely. The way we do this, and the way we're driving towards that vision, is fighting really two types of cybercrime. The first are technology-facilitated crimes that really target the most vulnerable members of the population. The second area of cybercrime we're focused on is fighting malware and reducing digital risk. And then the third area is using laws. We are a team of many lawyers around the world, and we're leveraging civil and criminal laws, sometimes old laws, sometimes new laws, to apply to this 21st century crime. I want to first start with the work we're doing in the vulnerable population space, particularly child exploitation. This wonderful technology we have, this fantastic thing that is something that can be used for so much good, the internet technology is sometimes, unfortunately, distorted and leveraged by the cyber criminals to do great harm. And child predators certainly are using the internet to do that very thing. And what they do is they trade in images of sexually abused children. 500 images of child exploitation will be traded online basically every minute of every day. And looking at this problem, we at Microsoft were thinking, is there a way that we can reduce that we can essentially prevent the re-victimization of children? Microsoft researchers worked with some researchers at Dartmouth College to develop a technology called photo-DNA. And what photo-DNA does is essentially, just as the name sounds, it gets to basically the underlying genetics, if you will, of a photograph. If a photograph has been deemed illegal by the National Center for Missing and Exploited Children or law enforcement, that photograph, there's a unique digital signature that's created of that photograph, and if it appears anywhere else on the internet and an organization has licensed photo-DNA from us, then that image the match is made and the photograph is taken down. So we have licensed photo-DNA to over 50 organizations around the world, including some of our competitors, because we believe strongly that this is an issue that absolutely transcends competition. And we've implemented it in our products, and I'm proud to say that just in 2014 alone, this technology not only created a safer online experience for our customers, but it led to the arrest of 58 individuals, child predators, in the United States. But we at Microsoft, if there's one thing you've learned this week, it's that we keep pushing forward. We know we can do more. And I'm just thrilled to announce that we're now launching photo-DNA in the cloud. You can implement it in your own organization so much easier than we could before. So instead of 50 organizations using photo-DNA, I'm really hoping we can get to 50,000 organizations. And I would just ask all of you in the audience today, please consider adopting photo-DNA in your organization. You can do your own part because it's not very difficult. I invite you all to go to the Microsoft.com/photodna website. You can learn more. The second area I said we're focused on is fighting malware and reducing risk. Now, the way the cyber criminals largely at the moment inflict criminal harm on a massive scale is through the use of what are called botnets. And a botnet is short for robot network of infected devices. And the way this works essentially is you have cyber criminals at the top who draft and deploy and disseminate malicious software through a variety of means. Maybe it's through unlicensed software. Maybe it's through luring a person to click on a website he or she shouldn't click on. Maybe it's in an email attachment. But one way or the other, the cyber criminals manage to inject malware in computing devices. That's often not just hundreds or thousands. Sometimes it's hundreds of thousands, millions of computers that now have malware at the bottom. They might use that botnet to steal financial information, to rob banks electronically, essentially a kind of 21st century digital robbery. They might use the botnet to send spam that drives fraudulent revenue that lines the pockets of the cyber criminals. They might use the botnet to launch denial of service attacks, essentially destabilizing organizations with making their computers crash by a simultaneous barrage of a botnet sending electronic signals. Working with law enforcement will take out the servers physically, the command and control servers that may be located in areas across the world, and then we get an order that redirects all those infected machines to Microsoft at the Cybercrime Center. So those infected machines that had been talking to the cyber criminals at the top, asking for instructions, what bank account should I steal from, what denial of service attack should I launch, are now coming to us. They're still asking the question, but we're not cyber criminals. We share that information immediately with law enforcement. We share it with internet service providers. We share it with computer emergency response teams. By sharing this information with these organizations, we can then move very quickly to try to get these machines cleaned as quickly as possible. I thought I would talk about one case and actually show you a little bit about how we marry up visualization and big data to generate insights that enable us to do our work better. So I want to talk about a case called the Citadel malware case. This is a case from June of 2013. This was one of the biggest botnets in history. We worked on this case with the FBI. At its peak, the Citadel had more than 1,600 separate botnets that were at work in support of the cyber criminals. At its peak, more than 5 million devices were infected in 91 countries. And the financial institutions we worked closely with estimated that more than $500 million, that's $500 million, was stolen over an 18-month period. But what I want to do now is actually show you the visualization of the Citadel case. So what you're going to see on the screen is the infection pattern of those 5 million devices. The redder it is, the more infections there are. Not surprisingly, when you look at the United States, where there are big cities, there's a lot of red. There were a lot of infections in those big cities. But one of the things that was interesting was when we looked at Europe, we saw something interesting. A lot of red, as you would expect. But whereas the population of Europe extends from the westernmost part of Portugal through east of Moscow, it appeared that the infection in Citadel didn't. That is to say, the infection pattern seemed to stop on a national border. So you can see right here, there seems to be a pretty sharp line there. We just couldn't understand why that would be. If you think about human disease doesn't tend to stop at a human-generated frontier, a boundary. Why would the Citadel malware stop on a border? We didn't know. So after we looked at this visualization, our forensic engineers took another look at the malware. They went into the malware lab and they tore apart the code. And what they discovered was it was no accident. In fact, the malware had been written so that it would not infect computing devices formatted in Russian, Cyrillic, or Ukrainian language. It's that the cyber criminals in this case were based in Russia and Ukraine. And they knew that if there were fewer victims in their countries, it would be less likely that Russian and Ukrainian law enforcement would prioritize this case, and they would be more likely to evade accountability for their actions. I don't think we would have had this insight had we just been looking at a list, a table of the numbers of infections country by country. It was actually bringing that data and marrying it with visualization that led us to this kind of eureka moment. But as much as we've done over the years, we're doing so much more now because we have taken our capabilities to the cloud. We are using, Satya talked about the suite, the Internet of Things suite. We are using 3 parts of that suite today in the Cybercrime Center. Power BI, Event Hubs, and HD Insights. We are using Parallel Data Warehouse. I showed you already, the map I showed you was Power Maps. That comes with Office 365 for free. But what's happened now is we've moved in recent months to this Internet of Things capabilities. We are now able to see things in near real time. Instead of waiting 36 to 48 hours, we are seeing things instantly. And that is pretty amazing when you're talking about the kinds of volumes of data we're talking about. So Ramnet was malware that was targeted on UK banks. So banks that were based in the UK, but account holders all over the world. And there are actually quite a number of account holders based in India and Indonesia in particular. This time, the minute those servers were ripped out, and the orders from the judges were executed immediately, redirecting those infected devices to us at the Cybercrime Center, we saw them right then. Using Event Hubs, we had instant insights. We could see immediately the number of devices touching us. Not only that, we could actually do analysis on those devices. Just as human diseases have strains, infected devices in Ramnet, there are different strains of the Ramnet malware. So those colors you see, the green, the yellow, the blue, those represent different strains of the Ramnet malware. And think about it, we're getting 500 million pings a day. Now the Ramnet case comes online because we're using Event Hubs and able to ingest the data and analyze it immediately. We're practically instantly not only taking in the data, but quickly distinguishing which data is which. Just an incredible, incredible step forward for us. The thing I'm most excited of all about is that we're now bringing this database, those 70 million IP addresses, to our products and services to protect our customers. So you may have heard this week about the Enterprise Mobility Suite. It's one of the most exciting offerings we have in the Microsoft Cloud. Azure Active Directory Premium is a part of EMS. And Azure Active Directory Premium has a console for the IT administrator that allows him or her to see if their sign-ins from customers or employees or partners, if they come from IP addresses with suspicious activity. And one of the key ways to see if there's suspicious activity now is using our 70 million strong IP addresses. So, if an employee of a customer using Azure Active Directory Premium logs in, there's a quick scan against the 70 million. And you might see, whoa, that IP address matches the zero access or config or Bamitol IP address. Those are 3 of the malware disruption cases we've done over the last few years. There is no silver bullets when it comes to cybersecurity. But to be able to take this massive volume of IP addresses associated with infected machines and build that into our products and services to keep our customers safer, that's really something to celebrate.